Hello, I'm Dr. Levon Hairapetyan, a business professor at Houston Baptist University. In this video tutorial, I will demonstrate how we can use predictive data mining and how we can implement the methods in Excel and in Analytics Solver. So basically what we are continuing chapter 9, which we started last time. In my previous video, I started chapter 9. Now we are continuing chapter 9. And today we will learn about a method, commonly used method called K nearest neighbors. So here K stands for how many, this is the number of neighbors which will be considered. If it's 5 nearest neighbor, that means 5 nearest neighbors will be used. And this method can be used for classification and for estimation. So the same method, K nearest neighbor, can be used either to classify a categorical outcome, for example, loan is default or no default, or credit card transaction, fraudulent or not, or it can predict a continuous outcome, for example, average balance. This K method is using the K most similar observation from the training set. I will give you an example just using when K is 5, just to be more clear. So for example, 5 nearest neighbor means it will use 5 most similar observation from the training set, and the closeness or similarity will be measured usually with Euclidean distance. Excuse me. How do we classify categorical outcomes with K nearest neighbors? Remember, categorical outcome, which we are discussing in this course, is binary outcome, either success or no success, like default, no default, fraudulent, no fraudulent, and so on. A nearest neighbor directly uses the entire training set to classify observations. Now, how a new observation will be classified as class 1? This is how it will be calculated. Again, I will give an example when we're looking 5 neighbors. If we use 5 nearest neighbor method, then how do we classify a new observation? We check the 5 nearest or closest observations to that new one, and we see how many of, what's the proportion of class 1 observations within those 5. And if that proportion is equal or greater than some cutoff value, usually it's 0.5, then we classify new observation as class 1, otherwise as class 0. For example, if we have a new observation and we look at 5 nearest neighbors and 3 of them are class 1, 2 of them are class 2. Therefore, the proportion for being class 1 will be 3/5, which is 0.6. 0.6 is more than the cutoff value. Therefore, we will classify this new object as class 1. The value of K, which means how many neighbors we will consider, can range theoretically from 1 to n, when n is how many elements do you have in training set. 2 extremes are when K is 1, that means you are classifying a new observation based solely on its closest or nearest neighbor. So if the closest neighbor is class 1, new observation will be classified as class 1. If the closest neighbor is class 0, then new observation will be classified as class 0. The other extreme is when we use total number of all observation in training set. So in this case, the new observation basically will see if total proportion of class 1 observations in training set is 50% or more, then we classify new observation as class 1, otherwise as class 0. Typical values for for K, or number of neighbors which we'll consider, ranges from 1 to 10. Here's an example of 10 observations or information about 10 customers. And for each observation, for each customer, we know average balance, age, and whether that customer defaulted on loan or not. 1 default, 0 no default. For example, this customer, the average balance is 192. It could be 1,000, units is not important. And then age is 31 and no default. Now we want to use these 10 observations or information about these 10 customers to classify a new customer. So if a new customer comes in and applies for a loan, then bank should be able to see how risky here is to give that new customer a loan. So based on this information, we will learn how we can classify either 1 or 0. If the new observation classifies as 1, that means it probably will default, therefore bank may reject the loan. So the way we will do that, by the way, we will do this in Excel just in few minutes. The first thing which we have to observe is that we have 3 variables in here, average balance, age, and loan default. And the scale of these variables are dramatically different. So here we have in tens and hundreds and thousands, and here we have just zeros and ones. So if we just use the raw data the way they are, then our calculations will be misleading because this average balance will dramatically dominate the other 2 variables. And these 2 variables will dominate the loan default. Therefore, the technique, which by the way we learned at the beginning of this course, is normalization. So we will normalize this data, we'll calculate z-scores, and I will remind you how to calculate z-scores. So in order to calculate z-scores, first we have to calculate average and standard deviation of balances and do the same for age, average and standard deviation. And then we will use this average and standard deviation to normalize. On this slide, the same data is just after normalization, it's presented on a graph. So when the x-axis is average balance after normalization in z-scores, and y-axis is age, again in z-scores. We have those 10 observations, as you remember. And here, the ones with the solid circles are observation with the default loans, and we have it's 1, 2, 3, 4, and 5. So these defaulted, and as you can see, these are the 5 observations. The first 5 observations defaulted, and the next 5 did not. So circles are used to present those observations which didn't default. So it will be 6, 7, 8, 9, and 10. So these circles represent the actual 10 observations or information about the actual 10 customers. This red triangle is a new observation. This is a new customer, and we want to classify this customer either default or not default. So in order to classify, here we will do this in Excel just in a second. Here I calculated a ratio or proportion of class 1 if we use 1 neighbor or 2 neighbors or 3 neighbors and so on up to 10 neighbors. So if we would use only 1 neighbor, the nearest neighbor, then the ratio in that nearest neighbor is 1, and I'll show you in Excel why it's 1. Therefore, since 1 is more than 0.5, we classify this as class 1, which is default. If we consider 2 nearest neighbors, which means the first 2 closest, then the proportion of class 1 is 0.5. Since 0.5 is greater than or equal to 0.5, then it's classified as class 1 again. However, when we consider 3 nearest neighbors, then the proportion of class 1 neighbors will be 0.33. This is less than 0.5. That's why the new observation will be classified as class 0. And so on, the same way like 8. If we apply 8 nearest neighbor method, then within 8 nearest neighbor, the proportion of class 1 neighbors is 0.63, which is more than 0.5. That's why this new observation will be classified as 1. Now let's go to Excel, and I'll open this file and demonstrate how we can calculate all these things in Excel. Basically, how we can do K nearest neighbor method, or apply this method or implement this method in plain Excel. So this is the same information which we have on slides, and this is the new observation. So these are my information about my 10 customers, and for each customer I have average balance, age, and whether loan default or not. And now the new customer came, and the average balance of this customer is 900, the age is 28, and we don't know whether he or she will default or not. That's what we're trying to figure out. And as we discussed, since this number, these variable scales are very dramatically different, we need to normalize them first. And in order to do that, we need to calculate average and standard deviation first. So I will calculate average. Average of all those 10 balances. And I'll calculate standard deviation and its sample standard deviation. Excel function to calculate sample standard deviation is stdev.s, that this dot net stands for sample standard deviation. So the average balance of those 10 customers is this number, and average standard deviation is this number. Now I will do the same calculation for age. Actually, I copied those formulas down. Now this is average for age, and this is standard deviation for age. Now I have averages and standard deviations. Now here I will convert these numbers into their corresponding z numbers, z values. The formula to calculate z values equals, now here I will calculate z score for 49. So it will be 49 minus the average, which is this, divided by standard deviation, which is this. So, therefore, the normalized value for 49 is negative 60.61. Now, instead of doing individually for each formula, I want to copy this formula down and calculate z-scores for all balances. But in order to do that, since all of them should use the same average and the same standard deviation, I will make this average, which is B14, absolute, and I will make it B15 also absolute. You can do that as you remember, clicking inside of the reference and then hitting F4 key. Now this formula is ready to be copied down. So these are my, these are my z-scores for balances. I will do similar calculations for ages. So I will convert these numbers into their corresponding z values. And so we will do this, again, z-score equals the value itself minus the average, which is mean, divided by standard deviation. And again, I will make C14 and C15 absolute, so I can copy down. So the first step is done. Now I have my normalized values for variables. Now in order to apply k nearest neighbors, like 1 nearest neighbor, 2 nearest neighbor, for this new observation, let me highlight this in yellow. So this is my new observation. I want to find which one is the nearest neighbor to this new observation, which 2 are the nearest 2 neighbors, which 3 are the nearest 3 neighbors, and so on. And the similarity here will be calculated based on the Euclidean distance. So basically what I will do here, I will calculate the Euclidean distance from this observation to new observation, and the same for the second, for the third. Let's do this. So remember the formula, it's square root SQRT and this number minus this squared plus this minus this squared and squared. So I implemented the Euclidean distance formula, which we used several times. You should be very familiar with this. And so this is the, excuse me, Euclidean distance of between observation, new observation and observation 1. Now I want to calculate Euclidean distance between new observation and to all other observations, which means, but right now I cannot copy this formula down. In order to be able to copy, I will make these two absolute, because for all these calculations, we are calculating distance from the same new observation. That's why I will make this G13 and H13 absolute. So G13 and H13. Where is my H13? H13 absolute. Let me show you the formula again. So this is my formula. Now I will copy down. So what we have here, let me just click a random cell and the next. What's the meaning of 1.24? This is Euclidean distance between new observation and observation number 5. Euclidean distance between new observation and observation number 9, and so on. Now, since we want to use K nearest neighbor, we should be able to see or specify which one is the closest neighbor to new observation, which two are the closest to, which three are the closest three, and so on. The simple way of doing it to just sort this table with respect to distance in ascending order. So let me just show you one technique, which if you try to highlight and go to data, try to sort based on distance, see, it didn't work. And the reason is that when you have a formula, because we have formulas in here, that's why it didn't work. If you want to be able to sort, you cannot sort the range which contains formula. You can sort data, the actual numbers. So what I will do, I will just select, and then I'll go to copy, and then I'll paste values. So this is the common technique if you want to convert the values of formulas into numbers. Now, if I click anywhere in here, you see that it's number. There is no formula in here. Now I can sort them. Select, data, sort, and I will sort based on the distance to the nearest. Yeah, this is correct. Smallest to the largest, correct. Okay. So now we have these numbers, as you can see, are sorted. Now, let's try to interpret what we got. What's the what we had in here is that this is the closest distance from the new observation and to 2. Therefore, the observation number 2 is the closest neighbor to this new observation. Observations 2 and 6 are the 2 closest neighbors to this new observation. Observation 2, 6, and 7 are the 3 closest neighbors to this observation, and so on. Like observations 2, 6, 7, 10, 1, 5, and 3 are the, how many? 7 nearest neighbors of this new observation. So therefore, if I want, let's say, if I want to calculate, to classify this new observation based on 3 neighbors, how I will do that? So these are my three neighbors. Among those three neighbors, one is class 1 and 2 are class 0. Therefore, the proportion of class 1 within three neighbors is 0.33, which is less than 0.5. Therefore, the new observation should be classified as class 0. Another example, if I want to use 2 nearest neighbor instead of 3 nearest neighbor, I want to use 2 nearest neighbors, and the 2 nearest neighbors we know that are 2 and 6. And within those 2 neighbors, one is class 1 and one is class 0. Therefore, the proportion of class 1 neighbors within those 2 neighbors is 0.5. So 0.5, what we have to do, we have to compare with the cutoff value. If our cutoff value is 0.5, by default usually it's 0.5. Then it's equal, 0.5 is equals to 0.5. Therefore, this new observation will be classified as class 1. So what we saw, if we use 2 nearest neighbor, this observation will be classified as class 1. But if we use 3 nearest neighbors, then it will be classified as class 0. So that's what we will do right here. Here, we will list the first one nearest neighbor, it will be just 2. Here we will have 2 nearest neighbors, will be 2 and 6. 3 nearest neighbor will be 2, 6, and 7, and so on. So I'll just, instead of typing all those data, I will just show you that I already did that. So the nearest neighbor, single nearest neighbor to new observation is 2. 2 nearest neighbors are 2 and 6. 3 nearest neighbors are 2, 6, and 7, and so on. So this is just a text which I typed. Here, what I did, I calculated proportion of class 1 if we use just one neighbor. If we use just one neighbor, and that one neighbor is 2, and 2 class for 2 is 1, right? It's class 1. Therefore, proportion of class 1 within this one neighbor is just 100%. Therefore, this new observation should be classified as 1 because 1, the proportion is 1 and 1 is more than 0.5, more than cutoff value. Now, if we use 2 neighbors, the 2 nearest neighbors are 2 and 6, and how I calculated this 0.5, 15, right, this one. So it's proportion of class 1 within 2 neighbors. Within 2 neighbors, we have 1 class 1, therefore proportion will be 1 over 2, which is 0.5. That's where this 0.5 came from. And then, since 0.5 is greater than or equal to 0.5, so we classify new observation as class 1. The same way, well, it continues, logic is the same way. If we use 3 nearest neighbors, and 3 nearest neighbors are 2, 6, and 7, then among those 3 nearest neighbors, 1 is class 1, 2 are class 0. Therefore, proportion of class 1 will be 1 over 3. That's where this 33 came from. No, I created the formula to calculate is what I did. I just added this divided by total number of neighbors. And so on. So this is 0.33. Now 0.33 is less than cutoff value, which is 0.5. Therefore, we classify new observation as class 0. So when we use 3 nearest neighbors, then the new observation will be classified as class 0. And the rest is done exactly the same way. So what we learned, let me summarize. And what we learned how we can, what's the essence of K nearest neighbors for classification. So the way we classify a new observation is we look at nearest neighbors. Let's say we want to classify based on 5 nearest neighbors. Then we check or find the 5 nearest neighbors to that new observation. And then we calculate proportion of class 1 neighbors within those 5. If the proportion is 0.5 or more, or in general, if it's the same as cutoff value or greater, then we classify new observation as class 1. Otherwise, we classify as class 0. So here I demonstrated how this K nearest neighbor can be implemented in just plain Excel. In the next lecture, I will demonstrate how we can do K nearest neighbor in analytics solver and how we can interpret the results of the outcome of the software. This concludes my lecture. Have a nice day. Bye-bye.